This brief tutorial will focus on solving connection issues that can occur when using the LeCroy Voyager USB 3 analyzer with real devices. We'll start with a discussion about USB 3 RX.Detect states. We'll explain briefly how the LeCroy Voyager can control those RX.Detect settings through termination. We'll give you step-by-step troubleshooting tips, and then we'll look at some live examples of connection issues. One of the key challenges that the early USB 3 test sites have encountered has been managing the RX-Detect states on the devices under test when you introduce an analyzer into the link. Some users may encounter unexpected behaviors the first time they use the analyzer. They may see the RX.Detect timeout condition, where one of the link partners enters compliance mode prematurely. You may see this as IPS traffic in the trace, where one side is repeating a specific pattern over and over while the other side is looking for the LFPS handshake. There could be signal lock issues where one or both sides are unable to perform the comma detect quickly enough. Again, we'll see IPS or garbage packets in the trace from both sides, usually a signal integrity issue on the DUTs themselves. Could be marginal cables. Try a shorter cable for devices that have equalization support. Some equalization parameters may be optimized to improve the signal lock here. If during link bring up you see LFPS polling primarily from one side, this could indicate that one of the devices has gone into RX.Detect timeout and is in compliance mode, or perhaps is in 2.0 mode. If you enable the 2.0 recording and you see 2.0 packets, then that indicates the two devices are not seeing termination and are negotiating down to 2.0 speeds. In order to avoid these type of analyzer connection issues, it's important to understand how devices do their presence detect in USB 3.0. Assuming the devices are powered on, when you connect them, they're going to look for VBus, then enter the RX.Detect state, where they'll charge up their receiver and look for termination. If they see termination, 18 to 30 ohms in common mode, it assumes it's a USB 3.0 link. It enters the polling state and starts sending LFPS symbols. They perform the link training and the link comes up. Now if you insert an analyzer in between the devices, assuming they're powered on, as soon as you connect that first device, he's going to see termination on the analyzer and start his LFPS detection. If he doesn't see an LFPS handshake from the far end within 360 milliseconds, he's supposed to go to timeout, entering this built-in test mode that looks like garbage in the trace. He stays in this compliance mode until power on reset. Even after you connect the other side, the link won't come up. All you'll see is the repeating compliance pattern in the trace, or maybe LFPS from one side. So to solve this problem, we added special detection logic to the analyzer front end, which serves as a proxy for the RX.Detect state. It simply waits for both sides of the link to be attached to the analyzer, and then it presents termination simultaneously. The two sides enter the polling state, they complete the LFPS handshake normally, and the link comes up. So this auto detection of far end termination works very well, and it really seamlessly handles hot plugging devices into the analyzer. You'll want to use it 95% of the time, but we do give you the ability to disable it. Within the USB Protocol Suite software, you'll see the recording options allow you to check manual termination for the analyzer ports. This can be very handy because it allows you to manually enable and disable the termination. I'll explain this in a minute, but first let's review. Leave it in auto mode by default. When you connect the first device, the terminations will stay off. Only when the second device gets attached are terminations presented to both sides simultaneously. In the unlikely case that there's some problem with the auto mode, we do have the ability to set terminations manually. When you set the radio button for manual, you'll see status off in the toolbar up above. And the idea with manual mode is that you'll connect one side, you'll connect the other. Then you'll use the mouse to change the status button to on. That will manually turn on both sides simultaneously and the link will come up. It can be useful to have this alternate method of connecting to help you try to narrow down problems. If you're still seeing issues in manual mode, such as you only get LFPS from one side of the link, it's recommended that you keep it in manual mode and power cycle the DUT side of the link. This will create a hot reset, the device will re-enter RX.Detect, and the link should come up normally. Alternatively, under Windows, you can choose Enable Disable the XHCI driver. This will put the devices into warm reset mode, which will re-enter RX.Detect state, and here the link should also come up normally. Back in the LeCroy USB Protocol Suite software, we'll show you a quick example of the auto mode. I go to the recording options, I click on the miscellaneous USB 3 tab, make sure it's set for analyzer only. Make sure the auto button is checked. I'll click OK. I've set the analyzer to trigger on a simple data packet, which is a convenient way to ensure the link is up. I hit record. I'll attach the device to the analyzer. You'll see that it's triggered down below. The trace uploads and places me right at the packet I triggered on. So using auto mode and hot plugging the devices allows the link to come directly up. I'll go ahead and close this trace. I'll go ahead and attach a different device that I know has issues with RX.Detect. I'm going to leave it in auto mode. I'm going to hit record and directly attach the device. It doesn't trigger. I'm going to hit stop to see what's happening, and you'll see LFPS polling from the device side, nothing from the host side. Now I'll go back into the recording options. I'll change the termination settings on the analyzer to manual mode. I hit OK. You'll notice that the status off indicates that the terminations are off on the analyzer. So now I'll again hit record. I'll use the manual button to enable the terminations, and when I do that, you'll see the analyzer triggers, the link comes up, and you can use the devices normally. So to summarize the sequence of troubleshooting steps, always start in auto mode. This is specifically designed to allow you to hot plug the device in the analyzer while the device is powered on. If you're having trouble, try setting to manual mode and use the manual on button. If you're still having issues, try power cycling the device side DUT. And lastly, enable disable the host driver will always bring the link up and down with a warm reset. The goal here is to find a sequence that allows you to consistently bring the link up with the analyzer attached. Please download the next tutorial for more tips and tricks on the Voyager analyzer.